Good morning, Yeshayah. Let's go ahead and get started with your math lesson review for today. So you corrected everything. It looks like you went ahead and corrected everything up to number 19, so that looks good. Set that to the side for now. Let's first now look at number 20. Okay, you were asked, or you were told that a 1-foot ruler broke into two pieces, so that one piece was 4 1/4 inches long. How long was the other piece? How long was the other piece? Your answer, you did your subtraction, and your answer was 6 3/4. Please think about what we've talked about many times before, and tell me why that answer is wrong and correct it. You were asked, how long is the other piece? If I asked you how long is something, would you tell me it's 6 3/4? Please correct your answer and add what's missing. Okay, 21, 22. Okay, I like the way that you worked out the problem and showed step by step, starting with your formula. Volume equals length times width times height. Then plug in your values for length, width, and height. Now, what you do need to do is write your units here as you go. You include your units as you go in your final answer. And when you plug those values in, you need to include your units. Okay, you got 24 cent cubed. Your number value is correct. I just want to show you, though, that there's two ways that you can represent cubic centimeters, and that's by writing out the words cubic centimeters, or the abbreviation for centimeters is cm, and then we write a little, it's not a subscript, that's I'm not sure. I can't think of what that's called when the number is raised up above the letters like that. But you just write your little raised to the third power sign next to cm. Cm is the abbreviation for centimeters once again. Okay, 23, 24 looks good. 25. Okay, you are asked to give the perimeter for this shape. So one side here isn't labeled on your image, and this side isn't labeled. So when you go to add up each side to tell me what the perimeter is, did you think about this part and this part and this side? And if so, I only see 1, 2, 3, 4, 5 numbers here. You need to think about and find out what is the length of this part, what is the length of this part, so that you can know the length of this side. And then you need to figure out what's the length of this part here, this side of your shape, and add all of those in to get your perimeter. Okay? Number 26. I want to show you, I wrote out for you how I expect to see this problem worked out. Similar to what you did here, starting with your formula and then plugging in those values for length, width, and height. Well, you would start with your formula. Circumference equals pi times diameter. So plug in your values. Pi doesn't have any units. The units for diameter is feet. Plug in your 2 feet. Multiply that and you get, yes, 6.28 feet. Now, the question asks for number 26. The question asks, which of that is closest? Which of that is closest? I'm sorry, which answer is closest to what you find? So you answered A. I'm going to tell you that's incorrect. How do you know whether 6.28 is closer to 6 feet, or if it's closer to 6 feet and 3 inches, or even if it's closer to 6 feet and 8 inches? Okay, you need to find out whether or not that 0.28 is closer to 1/12. 1/12 represents what? 1/12 of a foot or 1 inch. 1/12 of a foot is 1 inch. So you need to find out if that 0.28 of your 6.28, is that close to 1/12? Is that close to 2/12? Is that close to 3/12? Is that close to 4/12? Is that close to 5/12? Is that close to 6/12? Is it close to 7/12? Is it close to 8/12, 9/12, 10/12? Or you know it's not close to 12/12. But you need to find out, since you have to tell whether or not your answer is close to 6 feet or 6 feet and 3 inches. Remember, this 28 isn't 3 inches. I'm sorry, this 28 isn't necessarily 3 inches. It isn't necessarily 0 inches. But anyway, my point is that you need to find out what that 0.28 equals in terms of inches. And the way you would do that is by setting up an equation here, and you just think about it for a second. Take a second and think about it. And you say, well, okay, I need to know whether this 0.28 represents 1 inch, or 2 inches, or 3 inches, or 4 inches, or whatever. So you would set up an equation that is basically 0.28, because it's this 0.28 that you're interested in. You want to know how many inches that is. Okay, it's not 0.28 inches, right? It's not 0.28 feet. It's 28ths of a foot. But how many inches is that? So you're going to set up a little equation. 0.28 equals x over 12. This x could be 1/12, 1 inch, or 2/12, 2 inches, or 3/12, 3 inches, and so on. 1/12 of a foot is 1 inch. And then you would solve that by multiplying by 12 on the right side and on the left side to get x equals 12 times 0.28. Find out what x is, and that lets you know if that's 1/12, 1 inch, 2/12, 2 inches, 3/12, 3 inches, 4/12, 4 inches, and so on. Hope that was clear. Hope that was clear enough for you. But again, just to reiterate, you need to know if that 28ths, you need to know if 28ths, I hope you hear the THS on the end, if that's 1 inch or 2 inches. Okay, don't assume that it's 6 inches like you wrote letter A for your answer. You can't assume that's close to 6 feet and 0 inches. How do you know whether it's closer to 6 feet and 0 inches, or if that is closer to 6 feet and 3 inches, or even 6 feet and 8 inches? Okay, moving on. For 28, you've given me a list of numbers and circled one. What's your final answer? The problem asked for an answer in terms of a distance. You didn't give me any units. Okay, sloppy answer. Please indicate your final answer and give me some units. 29 was the average number of miles Selena rode per day. What was the average number of miles? You gave me just a number. Question asked for the average number of miles. You gave me just a number. Please don't make me have to ask you again and again for units. Units, units, units. Number 30, no answer. You told me you completed this lesson, so I wasn't expecting to see any questions unanswered. So go ahead and finish that up. Correct these 6 things that are wrong. Okay, think carefully, think thoroughly, and go ahead and correct that, and move on to lesson 107 today, which let's look at lesson 107 quickly. You're going to be going over the area of complex shapes. Okay, so we've got some shapes that look like maybe a rectangle with a square attached, maybe a square and a rectangle sitting side by side. Maybe you've got here a rectangle and a triangle, a trapezoid. Maybe you've got almost what looks like a square or a quadrilateral with a quadrilateral cut out of it, and you're going to learn how to determine the area of some interestingly shaped figures. All right, remember that the formula for area is always length times width, but you've got some things here that are interestingly shaped. So you're going to learn how to break those down into smaller shapes, or break the whole shape into parts that you can find the area of, and then add those two areas together. When you find the area of this trapezoid, if you break this shape up into two parts, a rectangle and a triangle, remember that the area of a rectangle is length times width. The area of a triangle is base times height divided by 2. So you would add the area of this rectangle to the area of this triangle, right? Okay. Have fun. Area of complex shapes. See you next time. Have a great math class.